When solving word problems in math, you'll often have to set up the equation that represents the scenario you're given. Depending on the information you have, sometimes you're able to draw a diagram and then label anything that you know. Other times you may be given a formula where you can write out what are each of the variables representing, and make sure you pay attention to the context. What restrictions do you have on those variables? In our first example here, we're told that we have a soccer field and we're given some information about the dimensions. I can begin by drawing the rectangular soccer field, and then we're told that the length of that soccer field is 5 times the width, but we're not told what that width is. So because we don't know what the width is, we're going to use a variable to represent that unknown side, and we want to choose variables that make sense to us. So we're going to choose W for width, and then we know the length is 5/3 times that width. So whatever that width is, we're going to multiply by 5/3, and that's going to give us the length of that. And then we're also told that the diagonal of that field is 116.6 yards. The ultimate goal in this question is to determine the dimensions of that soccer field. So the dimensions are the length and the width. We need to figure out the values of those two side lengths. And we know that because this is a rectangle, we have a right angle in that corner there. So I can go ahead and draw in that as a right angle. We also know that we can solve for missing side lengths in a right angle triangle using Pythagoras' theorem. So I'm going to go ahead and set that up here. So we have a squared plus b squared equals c squared, c being the hypotenuse of that triangle. We now have an equation with a variable in it that we are able to solve. It's important to note that we are squaring this entire first piece here. So I'm going to take that exponent and apply it to the numerator of that fraction, the denominator of that fraction, as well as that variable. So we're going to square this whole term and drop the brackets. And at this point, you have two choices. If you don't love working with fractions, because we're dividing by 9 on that first term, if I multiply this term by 9, that will cancel the denominator, leaving me just with that 25w squared. If I'm going to multiply this term by 9 to get rid of that denominator, I also would multiply this term by 9, so we'd have 9w squared, and then we would also multiply this term by 9, leaving us with 122,360 and 4 100ths. So that is one option. You can also work with these fractions, and we know that if we're adding fractions together, we need a common denominator. So my coefficient in front of that w squared is 1, so I'm going to write it as a fraction here, 1 over 1. My lowest common denominator is going to be 9, so if I multiply that denominator by 9, I also have to multiply the numerator by 9 to keep this equivalent. So we can see that 9 over 9 is equivalent to 1. I didn't change the question. We can now add those terms together. So we're going to keep the denominator the same and add the numerators. As my goal is ultimately to isolate w, I'm now going to remove that leading coefficient. Right now we have 34/9 times w squared. So because we're multiplying, I'm going to do the opposite. I'm going to divide out that 34/9. So when we divide fractions, we know we multiply by the reciprocal. So that's going to end up canceling. And then what we do to one side, we have to do to the other. So we're also going to divide this side by 34/9. We know that on the left-hand side, 34/9 divided by 34/9 is 1. That's going to cancel, leaving us just with that 1w squared. And now you'll need a calculator to enter this next part. But I'm actually going to back up here. So let's go back to the beginning. And if you're really not a fan of fractions, I'll show you how you can enter this into your calculator. So we're going to begin up in this second line with the 25/9. We're going to put that fraction in brackets. So we're going to go bracket 25 divided by 9 and then close the bracket on that fraction. And we're adding it to that 1. So we're going to go plus 1, and then we're going to press enter. Now this is going to give us a decimal. If we go back to the math button, number 1 is fraction, so we can go enter and then enter again, and it will convert it into a fraction in lowest terms for us. So by entering that 5/3 plus 1 on those like terms, we can get down to this value here. And so now what we're going to do is we're going to take that 13,000, so we're going to enter 13,595 and 56 hundredths. And now I want to divide by that 34/9, and that was the last thing that we calculated. So what we can do is divide, and instead of typing in 34/9 again, we can actually go second function and then press the negative key at the bottom. You'll notice in little painted letters here it says answer. So what your calculator is doing is it's taking the last value that you calculated and it's entering that in there. And then we can press enter, and that's going to give us the 3098.82, etc. We do not want to round until the very end. So we're going to keep that whole value in the calculator. And because this is an irrational number, it keeps going. Your calculator can only display so many numbers. So when we go to write this down, you're going to see that we just have those 3 dots there, indicating that that number is going to keep going. And we now need to get rid of that squared. So we know that the opposite of squaring is square rooting. So I'm going to square root the left. And when we square root the left, we know that the square root is going to cancel the squared, just leaving us with that w, which is what we want. And then to keep this balanced, we're going to square root the right. And so when we go to enter this in the calculator, we're going to go second function and then square root. And again, we need that whole value. So we're going to go second function, answer, and then enter, and it's going to give us that value there. So we can see that we have 59.990. Now, I have positive or negative because when we square root a variable, we can end up with a positive number or a negative number. So 59.99, etc. squared gives us that 3,598. But if we have a negative 59.99 squared, a negative times a negative also will give us that positive. But then think about the context. W is the width. We cannot have a negative value for w, so we're going to restrict that variable to the positive values. I don't want it to equal 0 because if the width is 0, we're not going to be able to have a diagonal that's 116.6 yards long. So we're going to take the positive solution and now check what we need to round to. So in this question, it says round to the nearest yard. So that means I'm rounding to the nearest whole number. Take a look at the number that follows it. In this case, because it's 5 or higher, it's going to bump that 9 up to a 10. We can only put 1 digit there, so that's going to bump this up to a 6. So we end up having 60 yards as the width. Now this question is asking for the dimensions. So we know the dimensions are both the length and the width. So once we've calculated w, we now need to calculate the length. We know the length is 5/3 times w. So we can go ahead now and take that equation, substitute in the value of w, and then solve for the length. Now again, it's really important that you keep this entire value. We don't want to round off until the very end. So when we go to put this in the calculator, we're going to keep that value. We're going to multiply. And again, I'm going to put in brackets. So we're going to have 5 divided by 3, 5/3. And then that's going to give us that value of 99.98, etc. And again, we're rounding to the nearest whole. So that means we're going to cut it off at this number, take a look at what comes after. It happens to be a 9, so that's going to bump this to a 10. So we're going to end up with 1 higher than 99. 100 yards. In our next question, we're told that the power, measured in watts, of a hairdryer is equal to the current in amps squared multiplied by the resistance in ohms. We need to express that statement as an equation, and it gives us each of those variables that we're going to use. So the first thing that you may want to do is even just make a list. It will help when it comes to actually solving this equation. So we know that power is capital P, and that's measured in watts. Current is capital I, measured in amps, and resistance is capital R, measured in ohms. So now we're going to take this statement that we're given. So the power is equal to, so is in math often means equals. So we're going to have power equals amps squared times resistance. So here we go. Power is amps squared times resistance. I'll have to rearrange this equation to isolate I. So if we want I by itself, we're going to do order of operations in reverse. Generally start on the outside and work our way in. There is nothing that we are adding or subtracting to that I that we can remove. So we're next going to remove anything that we're multiplying or dividing, which happens to be that R. So let's take that original equation and we're going to divide out the R first of all. So R divided by R is going to be 1. So that essentially is going to cancel out. And then on the left, we have that P divided by R. And then in order to get rid of that squared, we are going to square root both sides. And when we square root both sides, we're going to end up with just the square root of P divided by R. Now, based on this, we're going to now restrict these variables. So I know that P has to be positive or 0. R, because it's in the denominator now, is going to have to be greater than 0. And the last piece we're asked to determine is the amount of current that flows through a 1600 watt hairdryer that has a resistance of 8.82 ohms. So this is where it helps to go back in the beginning and really specify what each of those variables represents. So look at the units. We know that watts is going to be a measure of power. So you can even make a list on the side and write down P is going to be that 1600. We know that ohms is a measure of resistance, so that's going to be that R variable. And we're going to solve for the amount of current, which is I. I is already isolated when we rearrange this. Now, if we didn't do step B, you could actually take this original formula, substitute in for P and R, and then at that point just rearrange it. Okay, so because we've already rearranged it, let's take this formula, substitute in our values, and now we're going to enter this into our calculator. And pull your calculator out to make sure that you are able to enter this correctly. So we're going to begin by taking the square root, and then we're going to go 1600. And then we're going to divide by that 8.82 and get a value of 13.4687, etc. And because this question does not specify what to round to, we're going to just leave that as an exact number, indicating it keeps on going. But it's really important you include the appropriate units. So we know that I is measured in amps. And our final question is quite wordy, but what you want to start to do is to pick out the key pieces of information and to separate those from the extraneous information that you don't really need. So this particular question says Galileo discovered that the time for a complete back and forth swing of a pendulum, that's called a period, is directly proportional to the square root of the length and inversely proportional to the square root of the acceleration due to gravity. The constant of proportionality is 2 pi. Another way of saying this, so here's your clue. Another way of saying this is going to be a little bit simpler, is that the period is 2 pi times the square root of the pendulum length divided by the square root of acceleration due to gravity. That's the part we want, so we're going to highlight that. And we're now going to write an equation expressing the relationship between the period t, the pendulum, and its length. And again, it tells us what variables to use. So we're going to make a list of those on the side. It's going to help us later on. And then we're going to take this part here and translate that into an equation. So we have the period is. Remember, is in math often means equals. So we're going to start with the period, which is t, is. And then we have 2 pi times the square root. So times the square root of the length. Length we know is that L, divided by the square root of the acceleration due to gravity. Acceleration due to gravity is represented with that G. Another way you could write this is just to put both the L and the G directly under the radical sign. Both of those work. And then if the period is the time it takes for the pendulum to make one complete motion back and forth, that's going to have to be positive or 0. The length is also going to have to be greater than or equal to 0. And acceleration due to gravity, it's in the denominator here, that's going to have to be greater than 0. We're told that a pendulum and a wall clock has a length of 1.4 meters, and we're asked what is the period of that pendulum to the nearest hundredth of a second if the acceleration due to gravity is 9.81 meters per second squared. So the first thing we want to do is identify what is it that we're looking for. So you can even grab a highlighter or a pen and just circle. So we're looking for the period, and we know that period is represented by the variable t. So that's what we're looking for. And then fill in what are the other pieces of information we know. So that we're told what L is, we're also told what the G is. Now we're going to take the formula. So we're going to substitute in here the length and acceleration due to gravity, and then t happens to be isolated already, so we can just enter this into our calculator. All right, so you're going to do this along with me. The first thing we're going to do is enter the numerator. So I'm going to put this in brackets to tell my calculator that we need to calculate that whole value before dividing by the denominator. So we're going to go 2 and then pi, and then times the square root of 1.4, and now we're going to right arrow to get out of that radicand and then close the bracket. So this tells the calculator we're going to calculate the entire value of that numerator, and then we're going to divide by, and we don't necessarily have to bracket this, but let's bracket it. There's only one term there. So the square root of 9.81 right arrow to get out of that radicand, close the bracket, and we have a value of 2.37, etc. Now, because period is the time it takes, I can see that I'm measuring the length in meters. Gravity is meters per second squared, so I know that my time is going to be measured in seconds. It also tells me that we need to round to the nearest hundredth. So the nearest hundredth is 2 decimal places, so we're going to cut it off here. Take a look at the number that comes after. Because it is not a 5 or higher, that's going to stay as a 7, and then make sure you put the appropriate units on. And then in our final question, we're now looking for the length, so we're trying to solve for L. We're told that the pendulum will have a period of 2 seconds, that's going to be t, and our acceleration due to gravity is still going to be that 9.81 meters per second squared. So then it gives us some more extraneous information, basically just saying that this is going to be 1 second on the way there, 1 second on the way back. So the period is the length of time to get there and back again, 1 complete cycle. Let's substitute our values in, and now that we can see the L is over here, we're going to have to rearrange this equation in order to solve for this, beginning by removing the denominator. So right now we're dividing by the square root of 9.81. We're going to multiply to get that to cancel. All right, grab your calculator and let's enter that 2 times the square root of 9.81. And again, we're going to just keep that number in the calculator, indicate it keeps going. We're now going to remove any pieces that we're multiplying here. So we're going to divide out that 2 pi on both sides. So on the right, 2 pi divided by 2 pi will just leave us with the square root of L. So we're going to go in our calculator here now, divide by. It's going to put that answer in there, and you have to bracket this. And you could even try in your calculator, if you do not bracket that 2 pi, you will get a different incorrect answer. You have to tell the calculator we're going to divide by that entire product there. And now finally, we're going to remove that square root by squaring. So we're going to go ahead here and square both sides. And then in our calculator, again, we've got that answer in there. So we're just going to go squared, and it's going to put that answer there, and that's going to give us the value. This particular question does not indicate what to round to, so I'm just going to leave the exact value, but we do need to have the appropriate units. So length is measured in meters for this particular question.